Hello everyone, this is Unofficial Sando. Today, continue machine learning series. We'll go through to implement the binary cross-entropy loss. If you like my videos, you can support me by subscribing my channel. You can find the code of the video and also all of my video links in the description below. First of all, let's look at the forward parts of the binary cross-entropy loss, and this is basically the loss for binary classification problem, whether an entity is belong to a class or not. First of all, we get some feature of the entity as input, and we have some hidden layer here. Then eventually we output one logic, and then we have the signal activation function add on this single logic. This can remap the logic numerical value to the range of 0 to 1. So basically, you can think of the as a probability. Then we put this probability into a binary cross-entropy loss to decide whether we want to penalty the whole learning process or not. Then take a look at the binary entropy loss. Here n is the batch. Then here we take the average of the loss as a final loss. So here a little bit to understand the binary cross-entropy loss is, say, the yi here is our label. So if this entity is really is the class, and here is went away because 1 minus yi is 0. Then here we have our prediction, which is our output here. So if the probability is higher, basically just says our loss is lower because there is a minus here. So basically we don't want to penalize our learning because the learning is actually correct. Then in otherwise, if vi equal to 0, but if our probability is still high, here's because this thing is when going away and we only use this term. Since we have the inverse here, our losses still be high, which means we want to penalties for this false positive if the entity doesn't belong to this class. Very straightforward. Then let's look at the backward propagation. We usually want to consider both loss plus the sigmoid together. You will see why after I explain later. So right now we're just looking for the binary cross-entropy equation. Here I will use the x star to replace with x. Then x star is basically the sigmoid output. We'll take the input z. One thing to know that the epsilon's derivative actually equal to itself multiply 1 minus itself. Then the fun part is next. We're going to calculate the gradient of the loss with the input of the whole module, right? The input, the whole module will be the input of sigma, which is z. Then by applying the chain rule, basically is the loss divided by sigma and the sigma divided by z. Our loss divided by sigma, which is takes this equation, and the log x derivative basically is the sending to the x or sigma to the nominator. Then the same here, 1 minus x should be in the nominator because we have a minus here, so this will be turned to minus. Then sigma divided by z, which is equal to the sigma derivative. We replace this part as a derivative, so it's here. Then we combine these two parts, so the nominator will be the sigma multiplied 1 minus sigma. So those two parts will be removed. We have this part left, and also the y multiplied sigma. Here we have another part in the different sign, so those will be removed as well. So eventually, what's left is the label minus the sigma, which is the sigma output. Then that's our gradient during the backward propagation. Now let's look at how we implement the entropy loss. So from these videos, I'm going to use TensorFlow instead of the NumPy by using my previous video because I feel this way is more practical. People usually implement those stuff use TensorFlow or PyTorch. In this class, I have the class variable label and the sigma underscore x, which is sigma, to store the forward variable be using the backward propagation. In the forward, I'll take in the sigma input, which was z in previous slides, and the label. We call the sigma x label and calculate term 1, term 2. So term 1, term 2 basically is the binary cross entry loss part. Like this part is first term 1 and this part is term 2. One thing you need to be noted that when you do the log, here you need to be very careful because if the sigma x is very small, then basically it will show this whole value to a very large value, and sometimes in TensorFlow will be a NaN values. There will be a problem. So in here, I just adding a very small number. People usually call this epsilon in both log calculation. Eventually, I'll add in the term 1, term 2, and calculate the reduced mean in the last dimension. The first dimension is the batch, as always. Also, in the backward function, as we already stored the label and the sigma x, and we just take the minus between them and take the reduced mean of that. So basically, here is to return the one value as the gradient. So the size will be a 1. All right, so I also want to talk a little bit about the multi-class classification because the binary cross entropy basically used for a one class classification, and what will be changed if we want to predict if one entities belong to multiple class or not. So here, same input, hidden layer. The difference is that the output will be multiple logits. Usually this is the classes we want to do the classification. Here is reclass classification. Then we will use softmax instead of the sigma to do the activation functions. Eventually, we will obtain a list of probabilities. And also, all those values adding together should be equal to 1 by generating from softmax function. After we get this probability function, we feed into the cross entropy loss. The equation is here. After you know more cross entropy loss, you will realize that binary cross entropy loss is just basically a specialized form of the cross entropy loss. And also the backward propagation part for multi-class classification is very similar than the binary class classification. I will stop here. How to do the backward entropy loss, I'll leave you as the homework. But believe me, it's pretty similar than the binary class classification. Okay, so that's all I want to talk today. Hope you like this video. Then see you next time.